The fuselage is moved from operation to operation in the production line by means of an overhead monorail system. At a sub-assembly, the sheet metal fuel tank is installed in the forward part of the fuselage. It is covered by an aluminum cowling and is separated from the cabin by a stainless steel firewall. In a well-ventilated booth, as many as 7 coats of airplane dope are applied. Dope, a highly inflammable cellulose solution, increases the strength of the fabric and shrinks it still further. It acts as a filler, making the cloth airtight, and produces a surface that will withstand several years of wear and exposure. The landing gear supports the airplane when it is resting on the ground. It functions as an efficient shock absorber during landings and takeoffs. The shocks of landing are absorbed by rubber shock cords. Telescoping steel struts transmit these shocks from the wheels to the cords. Shock cord consists of many small strips of rubber about the size of common rubber bands, all bound tightly together by a woven fabric cover. The result is a strong, highly resilient rubber ring, which, because of this method of assembly, places the telescoping strut sections under considerable compression. Rubber, when held under high tension and exposed to oil and gasoline, deteriorates rapidly. This can be greatly retarded by protective boots made of an oil and waterproof material. They are slid into place and cover the cords of the completed shock absorber assembly. The welded tubular steel framework of the landing gear is primed by immersion in a zinc chromate solution. It is covered and finished in the same manner as the other fabric-covered surfaces of the airplane, and is completely assembled before being installed on the fuselage. Brakes of the internal expanding hydraulic type are installed. They are actuated by foot pedals located in the cabin. The large, soft donut tires used on an airplane absorb a great portion of the landing stresses. They improve performance on soft or rough ground. Hubcaps protect the axles and bearings from mud, dust, and water. The tail assembly provides stability and controls the direction of the airplane in flight. The movable surfaces are operated by the control stick. The frames of the tail surfaces are constructed of welded steel tubing. After they have been primed and covered, the fabric undergoes the same shrinking process to which the fuselage cover has been subjected. Application of airplane dope in the same manner as received by the fuselage makes these frames ready for final assembly. The lifting surface of an airplane is the wing. It must be light in weight, yet strong enough to support many times the weight of the airplane. Ribs are shaped to give form to the wing. They are made from strips of lightweight aluminum alloy which are drawn through a die on the drawbench. After being formed, these strips are cut to proper length for their intended purpose. Various cross-sectional shapes of great strength are formed by using different dies. One of the T-shaped sections is crimped and bent to form a cap strip, which is the continuous member which forms the outer edge of a rib. Fabricating ribs in this jig gives them the exact shape necessary for greatest lift with least air resistance. These rib braces are so located that they terminate at the points of greatest load on the wing. This design is essential, for ribs are really small trusses used to transmit the lift from the wing covering to the spars. The permanent joining of these members, since they are aluminum alloy, is done on an automatic riveting machine. This work is done in less than 1/3 the time required by the former hand method. Holes are punched, the rivets inserted and headed in 2 operations. This 8-ounce rib can support several hundred times its own weight. Spars are the main structural members of the wing. For light airplanes, they are made from carefully selected, straight-grain, kiln-dried spruce. The spruce has been joined, milled, and varnished. A jig has been used to drill accurately the holes for the attachments. When the airplane is in flight, the lift covering is transmitted to the spars by the wing ribs. In assembly, the legs are slid onto the spars and fixed at positions which were determined when the airplane was originally designed. These locations depend upon the wing to be supported by the wing. Light airplanes have ribs farther apart than heavy airplanes. Internal struts and tie rods resist drag loads on the wing in flight and retain the true form of the wing. The drag loads subject the struts to compression and the rods to tension. Since the attachment holes have been pre-drilled in the spars, the compression struts are quickly bolted into place. Terminals have been placed in the struts for the attachment of tie rods. A left-hand thread is on one end of the tie rod and a right-hand thread on the other. An experienced workman adjusts them to the correct tension. Standardization in the aircraft industry is most evident in aircraft fastenings. If the fastenings are designed for disassembly, they are safetied against vibration. Castellated nuts are most commonly used and are kept in place by cotter pins. A pulley must be used when a control cable changes direction more than 15 degrees. These pulleys are made from a durable plastic-bound fabric base which will not fray the cable. They are provided with a guard preventing the cable from slipping off and have either plain or ball bearings. The leading edge of the wing is the section extending forward from the front spar. Since this is the section that directs the air back over the airfoil, its curve or camber must be retained. In order to preserve this camber against fabric tension and air pressure, false or short nose ribs have been placed between the form ribs in the leading edge.